Yes, cables that are run through holes in wood I-joists that are 16 inches on center are considered bundling. When multiple current-carrying conductors are bundled together, the heat generated by each conductor cannot dissipate as efficiently as it would if the conductors were individually installed in free air. This leads to an increase in conductive temperature. To prevent overheating and potential insulation damage, the National Electrical Code, or NEC, requires ampacity derating for bundled conductors. Ampacity is the current carrying capacity of a conductor expressed in amps. Derating means reducing the allowable ampacity of a conductor to compensate for the increased temperature due to bundling. The NEC provides tables that specify the derating factors to be applied based on the number of current-carrying conductors in a bundle. These derating factors are expressed as percentages. To determine the allowable ampacity of bundled conductors, you must first find the base ampacity of the conductor from NEC table 310.15. Then, you must apply the appropriate derating factor from NEC table 310.15 based on the number of current-carrying conductors in the bundle. For example, if you have 4 to 6 current-carrying conductors bundled together, the derating factor is typically 80%. This means that the allowable ampacity of each conductor is reduced to 80% of its base ampacity. It is essential to consult the latest edition of the NEC for the specific derating factors and requirements applicable to your situation. The NEC also provides guidance on how to determine whether cables are considered bundled. Generally, cables that are installed in contact with each other for more than 24 inches are considered bundled. This applies even if the cables are not physically tied together. When cables are run through holes in wood I-joists, they are typically considered bundled because they are in close proximity to each other and their heat dissipation is restricted by the surrounding wood. The 16-inch on-center spacing of the I-joist further contributes to the bundling effect. To mitigate the effects of bundling, there are several strategies that can be employed. Firstly, you can increase the size of the conductors to compensate for the ampacity derating. For example, if you need to carry 20 amps and the derating factor is 80%, you would need to use a conductor with a base ampacity of at least 25 amps because 20 amps divided by 0.80 equals 25 amps. Secondly, you can reduce the number of current-carrying conductors in each bundle. This can be achieved by separating the cables into multiple bundles or by using multi-conductor cables with fewer current-carrying conductors. Thirdly, you can install the cables in a way that allows for better heat dissipation. For example, you can use cable ties to space the cables apart from each other, or you can install them in a ventilated raceway. It is important to note that the NEC also requires that the ampacity of conductors be derated for ambient temperature. If the ambient temperature exceeds 86 degrees Fahrenheit, the ampacity of the conductors must be derated in accordance with NEC table 310.15. The ambient temperature is the temperature of the air surrounding the conductors. In addition to ampacity derating, it is also important to consider the voltage drop in the conductors. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidance on how to calculate voltage drop and how to select conductors that will minimize voltage drop. The NEC recommends that the voltage drop in branch circuits should not exceed 3% and the voltage drop in feeders should not exceed 5%. To minimize voltage drop, you can use larger conductors or you can reduce the length of the conductors. It is also important to ensure that all electrical connections are properly made and that there are no loose connections. Loose connections can cause excessive voltage drop and can also create a fire hazard. When installing cables in wood I-joists, it is important to follow the manufacturer's instructions for drilling holes. The holes should be located in the center of the warp of the I-joist and they should be no larger than the maximum size specified by the manufacturer. Drilling holes that are too large or that are located in the wrong place can weaken the I-joist and compromise its structural integrity. It is also important to avoid drilling holes in the flanges of the I-joist, as this can significantly reduce its strength. When pulling cables through holes in wood I-joists, it is important to use a lubricant to reduce friction. This will make it easier to pull the cables and will also help to prevent damage to the insulation. The lubricant should be compatible with the cable insulation and it should not damage the wood I-joist. It is also important to avoid pulling the cables too tightly, as this can damage the insulation and can also put stress on the I-joist. After the cables have been installed, it is important to inspect them to ensure that they are properly supported and that there are no signs of damage. The cable should be supported at intervals not exceeding 4.5 feet. This support should be designed to prevent the cables from sagging or coming into contact with other objects. If any damage is found, it should be repaired immediately. In addition to the NEC, there may be local codes and regulations that apply to the installation of cables in wood I-joists. It is important to check with the local authorities to ensure that you are complying with all applicable requirements. Understanding cable bundling and ampacity derating is essential for ensuring the safety and reliability of electrical systems. By following the NEC and other applicable codes and regulations, you can help to prevent overheating, insulation damage, and other potential hazards.